Welcome to the WanderLearn podcast. I'm your host, Tapon. In this episode, it's a special episode for my patrons. I love you guys. Only you guys get to hear this episode. I recorded it because I was tasked to interview two NASA astronomers, and I kept the recording for myself because I know they're going to edit it to death, and the public is only going to hear a fraction of my interview. So I wanted to share you that special exclusive interview that if it got out there, I would probably get killed for it. Probably you're going to be the only people who are going to actually listen to this interview, and I hope you enjoy it. Special salute to Kathy, Kennedy, Edgar, who's out there, and she helped make this podcast possible. In fact, every single one of you helped make it possible. So thank you again. I'm going to have a second one out where I interviewed the second guy from NASA, another astrophysicist. His name is Jack, and it's another great coup. Super awesome. Enjoy.
Hi, my name is Ross Belikov, and I work at NASA. I work on exoplanets, which are planets orbiting stars other than the Sun, and I develop technology to observe them. Tidal forces occur when you have two bodies orbiting each other, or more bodies in general. And what happens, for example, let's take the case of Earth and the Moon. The Moon exerts gravity on the Earth, and it pulls a little bit stronger on the side that's closer to the Moon than the side that's away from the Moon. And whenever you have this difference in gravity forces, it effectively stretches the Earth. And this stretching is what we call the tidal force. And because of the stretching, you have tidal waves and tides on Earth. But more generally, the whole Earth kind of gets deformed into a slightly elliptical shape. And on top of that shape, you have oceans that are a little bit higher than the land, and that's what creates tides. An extreme version of tidal force in the solar system. I don't know off the top of my head, but Io orbiting Jupiter probably might be the most extreme version. And so tidal forces, of course, are greater if the object that creates the tides is more massive. So Moon creating tides on the Earth Moon is not that massive, so the tides on Earth are very small, but Jupiter creating tides on its moon Io is much, much more massive than our moon or any other body in the solar system other than the sun. And so it creates huge tides on Io. Tides are also a strong function of how close the two bodies are together. And so Io is pretty close to Jupiter. So weather is a funny thing because weather typically requires an atmosphere, and Io has almost no atmosphere. So Io then would, technically speaking, doesn't really have weather by many definitions of weather. But one way to ask that question is what it would be like to be on Io, what it would seem like. Well, so Io has huge volcanoes. It's the most volcanic body in the solar system. So you would see eruptions and magma lakes and oceans and all of that stuff there. But surprisingly, it wouldn't be, on average, it wouldn't be hot. On average, the average temperature of Io is 110 degrees Kelvin, which is like minus 160 degrees Celsius. So it's pretty frigid unless you're standing close to one of these volcanoes. And the reason it's so frigid is because it's so far away from the sun.
And do you know how long the days are on Io?
It's about 1.8 Earth days. And so a day is basically, if you define a day by how often you have how often do you have solar day and night cycles, then it's about 1.8 days.
You would think that Io would be tidally locked, and so
yes.
In other words, it wouldn't even have a day at all. It would be fixed.
So it is tidally locked to Jupiter, but it's still, as it orbits Jupiter, different phases of it get illuminated by the sun. So you get sunsets and sunrises every 1.8 days. But at the same time, Jupiter is always hovering above the same spot in the sky because it's tidally locked. even though the same face of the moon always faces the Earth, it undergoes different phases, a given spot on the moon is sometimes bright and sometimes dark as it goes through crescent phase and gibbous phase and so on. That means that any given spot on the moon undergoes daytime and nighttime. The same thing would happen to Io as well. And by the way, Jupiter on Io would loom huge. It would cover close to 20 degrees on the sky, close to 10 degrees on the sky, roughly 20 times larger than the size of the moon as it appears on Earth. So you can imagine, scaling the moon up 20 times, and that's how big Jupiter would be from Io. Can tidal forces cause earthquakes and tsunamis? Absolutely. It just depends on how strong the tidal force is, which in turn depends on how massive the perturber is, so Jupiter in the case of Io, for example, and how close the two bodies are together. So for sufficiently strong tidal forces, you can have arbitrarily strong earthquakes, arbitrarily high tsunamis, like kilometer sizes even, which is almost incomprehensible. And for a sufficiently strong tidal force, you can even completely melt the planet. And in fact, if you put Earth in Io's orbit, that's probably what will happen until Earth gets tidally locked. If Earth continued to spin, if it wasn't tidally locked, then Jupiter would exert tidal forces on Earth strong enough to tidally lock it on very short timescales, astronomically speaking, probably less than a century or so. To tidally lock and to slow the spin of Earth on such short timescales, it would require melting the entire surface most likely. And so it's not going to be a pleasant time to be on the Earth if we to suddenly place Earth in Io's orbit around Jupiter. So the question is, what would happen to the Earth if we were to place it in the same orbit around Jupiter as Io is around Jupiter? And so that's a complicated question because it depends on, for example, did we just place the Earth there, or has it been there for a while? If you just place it, and if it spins at the same rate as it does now, then it will not be tidally locked. And the tidal forces that Jupiter would exert on Earth in that case will be orders of magnitude stronger than the tidal forces now. So you would first experience extreme earthquakes, tsunamis, fire and brimstone, mass hysteria, cats and dogs living together, and it would become uninhabitable pretty quickly. And eventually, the whole surface would just melt. And the Earth will become a huge global ocean of lava. And that would completely sterilize it. And in something on the order of decades or centuries or something like that, it will eventually become tidally locked. Then it would cool, and it would continue cooling until it's actually colder than it is right now. So it will become a frigid planet. Remember, the average temperature on Io is something like 110 Kelvin, which is much, much colder than it is on Earth now. Once it's cold like that, then it would also not be habitable anymore. The earthquakes and all of that stuff will continue. All the oceans would probably evaporate once it's in its liquid lava state. So you would have all of these interesting and sterilizing effects going on the Earth. So the question is there a scenario for Earth orbiting Jupiter where life could exist on Earth? That's actually a great question, especially in the context of exoplanets, which are planets orbiting stars other than the Sun, because scenarios like that might exist and almost certainly do exist around other stars. Actually, the movie Avatar has this habitable moon, Pandora, around a gas giant, around the nearest star, Alpha Centauri. So the short answer is yes, we think that habitable moons around gas giants like Jupiter are indeed possible. And what that would require is for Jupiter to be closer to the star, to where it's within the habitable zone. If it's beyond the habitable zone, you might still have a warm planet, warm enough to be habitable, but it would require the tidal forces to be strong enough to heat it, to contribute to its heat, because it's otherwise would be too cold. And those tidal forces could be dangerous to life because they would induce earthquakes and tsunamis and all of that fun stuff, or not fun stuff depending on how you look at it. So it's a trade between if Jupiter is in the habitable zone, then and the Earth is far enough away from Jupiter to where the tidal forces are not strong enough to cause huge earthquakes, then I think you're fine. So that's probably the best scenario for a habitable moon around a gas giant. I think even Homo sapiens can survive in a situation like this. So, I can imagine a scenario where Earth is in, say, Callisto's orbit, and Jupiter is 5 times closer to the Sun than it is now. I think in that situation, there are probably lots of effects I'm not considering. There's always things in astronomy that creep up. But I think there's a good chance that Earth will continue to be habitable in that case. So the question is, if Earth is orbiting Jupiter and Jupiter is in the habitable zone, then would the Earth get bombarded by asteroids? And would Jupiter's magnetic field protect us from Sun's radiation? So let me answer the Sun's radiation first. I think the answer is yes, assuming you are close enough to Jupiter to where you're within its protective shield, but not so close that the magnetic field creates harmful radiation on the planet. Just to give you an example, if you're as close to Jupiter as Io is to Jupiter, the radiation you would experience from ions trapped in Jupiter's magnetic field is an order of magnitude more per day than the lethal radiation for a human being. So you would pretty soon get like acute radiation sickness syndrome and die within a few days unless you have shielding from that radiation. So you don't want to be as close to Jupiter as Io is to Jupiter. But if you're farther away, then to avoid those harmful effects, and Jupiter's magnetic field would indeed protect you from Sun's harmful radiation, just like the Earth's magnetic field does right now. If Earth orbited Jupiter, would it protect us from asteroids? Because just in a way, it's protecting us now because it's deflecting asteroids, or would it bombard the Earth with asteroids because it's in some sense an asteroid magnet? And I think that it would protect us because even though it's you can think of it as an asteroid magnet, it's a magnet only in the sense that it causes the asteroids to come closer to it once, and then it deflects them out of the solar system or into the sun or something like that. And I think the chances are pretty low that during those kinds of events, an asteroid will hit the Earth. You get problems when asteroids linger in the solar system for millions of years and occasionally collide with the Earth. And Jupiter kind of sweeps them away. And I think that sweeping away effect will work the same way even if Earth was orbiting Jupiter. And I think the chances of an asteroid hitting Earth would probably not significantly increase if it was around Jupiter. But that's more of Jack's area of expertise. So if he disagrees with that, I would go with his opinion on that. So the question is, what is the surface and atmosphere of Venus like? The surface of Venus is a hot hellhole. It's many hundreds of degrees hotter than the Earth's surface is. So it's like hotter than the oven, and you don't want to be there. It's a hot hellhole. There were spacecraft that landed on Venus that only survived for maybe an hour or so before they melted. The atmosphere on the surface is also not very hospitable. It's 95 times thicker than Earth's atmosphere is. So if you were to kind of swipe your hand through the atmosphere, you would feel 95 times more air resistance than you feel on Earth. So you can imagine, it would be like going through molasses or something like that. Not quite that thick, but much thicker, noticeably thicker than the Earth. But the interesting thing about Venus is that it's the only place in the solar system other than the Earth which has Earth-like temperature, pressure, and gravity. And what I'm referring to is 50 kilometers up from the surface. The atmosphere is thin enough and colder than on the surface and is comparable to Earth's. So if you have an aerostat city 50 kilometers off the surface of Venus, then conditions are kind of habitable, except for the acid rain and the acid in the atmosphere. But if you can protect yourself from that, then you don't need to have a pressure suit and you don't need to have a thermal suit. You just need a gas mask and protection from the acid. So I like to think of Venus as its surface is just 50 kilometers too low. Its surface is kind of like this. You can imagine drilling down 50 kilometers down on Earth. It also would be a hot hellhole. That's kind of what Venus is like. So with sufficiently advanced technology, you could have a cloud city on Venus. And there's opinions differ on whether it's easier to terraform or it's easier to have a habitable colony on Venus as a cloud city or on the surface and terraform it. I think that it's a little bit easier to have a cloud city than terraform Venus. But again, opinions differ. The question is, what would we need to do to terraform Venus? This is getting into technology that's well beyond the foreseeable future and centuries or millennia in the future. So this is all speculation, but it's fun to speculate. And there's no laws of physics that preclude us from terraforming planets and terraforming Venus in particular. It's just a question of the will and the technology. So there are a few things that we would need to do. First of all, we would need to cool Venus if we want to live on its surface. And to do that, there's many different proposals that have been circulating, and some of them include shielding Venus from the sun by putting these gigantic shrouds. Some of them include thinning the atmosphere of Venus and having less of a greenhouse effect going on. Because the reason Venus is so hot is because it has a runaway greenhouse effect. So you take away that, you can significantly improve the temperature. Generally speaking, temperature is one thing you need to improve. Then atmospheric pressure is another thing you need to figure out how to do. So you need to thin the atmosphere of Venus, and maybe with chemical reactions to absorb the carbon dioxide that's in the atmosphere is one possible way to do it. But again, it's getting very, very speculative. So to do all of these things, again, we don't know how to do that very well or how long it's going to take, but it's at least centuries or millennia. But it is possible. Mars, I think, is much easier to terraform than Venus. the advantage of Mars is that you can survive on the surface in a spacesuit already for at least some time. And there's radiation issues and a few other things, but you don't need to contend with very high temperatures on the surface and very high pressures on the surface, right? And the way I like to think of Mars is that, so compared to Venus is like the surface of the Earth, but that's too low. It's 50 kilometers too low, so it's very hot and temperature is very thick. Mars' surface is kind of like the surface is too high. The surface is in the stratosphere. Similarly to Earth's stratosphere, the pressure on the Mars surface is a little bit less than 1% of Earth atmospheric pressure. And it's also pretty cold there, just like in the stratosphere, it's pretty cold. And you can imagine surviving in the stratosphere, right, of Earth. So similarly, you can already survive on Mars. And the key things to solve are, again, temperature, atmosphere. You want the atmosphere to be breathable and thick enough to where you can survive without a pressure suit. And you also need a magnetic field or something to protect yourself from the radiation of the sun. And there are many different ways and techniques to raise the temperature and raise the pressure on Mars. And one technique that I like, and it's been somewhat popularized by Elon Musk, is to nuke Mars or crash an asteroid into one of the polar caps. The south polar cap is usually the one that's preferred. And if you do that, that would add a little bit of temperature, and it would vaporize a lot of carbon dioxide in the south polar cap to where it might jumpstart a runaway greenhouse effect that would release all the frozen carbon dioxide in the soil and may increase the temperature and pressure to perhaps somewhat livable levels. There's a lot of uncertainty into whether this would work at all and how much of an asteroid you need or how much energy you need to get that going. But that's one path. And something like that doesn't require thousands of years like it does on Venus. We might only be talking about centuries or so. The question is, can you describe the nearest star system to us, which is Alpha Centauri, and what do we know about it? So Alpha Centauri is a triple star system. It consists of two stars that are relatively sun-like. They're called A and B, and a third star that is much dimmer and less massive than the Sun, called Proxima. The two sun-like stars orbit each other, and the third star, Proxima, orbits much farther away, this AB pair. We don't know of any planets around the two sun-like stars, but chances are that there are planets there, and chances are that there are habitable planets there as well. And you might think that in the two-star system that would destabilize planets, and indeed, planets like Jupiter that are 5 times farther from the host star than the Earth is, those would be unstable. Those are impossible around the AB star system. But habitable planets like the Earth are possible around each one of the A and B stars. And if they do exist there, then those are probably our best candidates to find life or to search for life, because Alpha Centauri is 2.5 times closer than the next nearest sun-like star. So by imaging planets or by detecting planets there and characterizing them, you're going to get a lot higher signal to noise, a lot higher signal, a lot better signal to noise than around pretty much any other star for a lot of techniques. So it's a very exciting star system for us to analyze. Now, the third star, Proxima, is also a very exciting star, and in particular because a potentially habitable planet is known to exist around it. Since the star is so small, this planet has a very short year. It's something like 11 days. That's how long a year is around there. And it's also tidally locked. most likely. So there are some questions of whether it's habitable. It could be habitable, but it might be. There also has been an announcement this year of a possible second planet in the system, which is farther away, so it's much colder, and it's about a couple of times larger than the Earth. So we know of a planetary system that's basically right next door to us around this triple star system. And it would be very exciting to see in the coming years and decades what new instruments will reveal around the known planets and any unknown planets in that system. My pleasure. Thank you very much for all these questions.
And that concludes this episode of the WanderLearn podcast, where we explore travel, technology, and transformation. If you'd like to see the show notes with links to what we talked about, or if you'd like to comment on the show, or if you'd like to ask me a question, then go to WanderLearn.com and click on this episode. If you'd like to connect with me, just remember Tapon. That's my first initial and my last name. Tapon is the username I use on all social media. You can also get to my website by going to ftapon.com. And here's one last reason to remember Tapon. If you like what I do and would like to get rewarded for supporting my projects, then go to patreon.com/ftapon. That's where you can pick up some remarkable rewards for as little as $2 a month. And now for 5 quick favors. Number 1, subscribe to the WanderLearn podcast. 2, download it. 3, share it. 4, review it somewhere. And 5, sign up for my newsletter at WanderLearn.com. Our theme music was composed by Eric Stratman. This is Francis Tapon, encouraging you to wander and learn.